In this episode, we're going to focus on a skill that doesn't sound glamorous, but saves real time and reduces real mistakes: filtering. When you work with automation code over weeks and months, the repository becomes a growing history of changes, versions, fixes, experiments, and decisions. If you cannot quickly find the specific change that matters, you end up relying on memory, guesses, or broad searches that return too much noise. Filtering is how you narrow your view so you can answer focused questions like, what changed between these releases? When did this behavior start? Or which commits touched this file? For beginners, the goal is not to memorize commands, but to develop a mindset of asking precise questions and then using Git's built-in ways of narrowing the answer. In deployable automation, speed and accuracy matter because the faster you can find the right evidence, the faster you can fix problems without creating new ones. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. The first thing to understand is that Git history is rich, and that richness is both the value and the challenge. Git records commits, authors, timestamps, messages, file changes, and relationships between branches and tags. Without filtering, that richness becomes overwhelming because everything is visible at once. Filtering is the act of choosing a smaller slice of history that is relevant to your current question. Beginners often scroll through a long history and hope something jumps out, but that approach fails as projects grow. A better approach is to start with the question you need to answer and then decide what dimension you can filter on. You might filter by time, by author, by file path, by branch, by tag, or by text inside commit messages. Each filter reduces noise and increases signal, which is exactly what you want when automation behavior needs to be explained quickly. A very common filtering need is to compare versions, because version labels are how teams communicate what code was deployed. If you use semantic versioning and tags, you will often want to see what changed from one version to another. This is where filtering by tags becomes powerful, because tags can represent release points that matter operationally. When an incident happens, people often ask, what changed since the last good release? And filtering between two known version tags gives you a focused answer. Without filtering, you might inspect dozens of unrelated commits and still miss the one that mattered. With filtering, you can narrow the view to the exact range that could have introduced the problem. This also supports rollback decisions, because you can see whether a change was isolated or part of a broader set. In automation, knowing the scope of change is often the difference between a safe rollback and a panic-driven guess. Another useful approach is filtering by file or path, because many questions are really about which part of the system changed. If a specific automation component is misbehaving, you want to focus on commits that touch that component, not on unrelated documentation or adjacent tooling. Filtering by file helps you connect a behavior change to the portion of the codebase that likely caused it. It also helps you avoid a common beginner mistake, assuming that because something broke, the most recent commit must be responsible. In active repositories, many commits may be happening across unrelated areas, and the relevant change might be buried among them. When you filter by the impacted file or folder, you reduce the chance of misattribution. Misattribution is costly because it leads to the wrong fixes, and wrong fixes can compound incidents in automation-heavy environments. Filtering by time can also be surprisingly helpful, especially when you are coordinating across distributed teams. If you know a behavior started on a specific date or during a specific week, you can narrow your search window. Time-based filtering is not perfect because a change can be committed earlier and deployed later, but it is still a valuable first cut. Beginners often overlook time filtering because it feels less precise than file filtering, but time can be the strongest clue you have when you are aligning changes with external events. For example, if a deployment occurred on a certain day and problems began immediately afterward, time filtering helps you identify which changes were even candidates. In automation, timing matters because jobs run on schedules, pipelines run on triggers, and configuration changes happen in Windows. Filtering by time helps you connect the dots between repository history and operational history. Filtering by author is another dimension that can be useful, not as a way to blame, but as a way to find context quickly. If you know a particular teammate was working on a feature area, filtering by their commits can reduce the search space. More importantly, author filtering can help you find the best person to ask for intent when a change is unclear. Beginners sometimes treat authorship as just metadata, but in a real incident or review, authorship is a navigation tool. It tells you who can explain why a decision was made, what constraints were considered, and what trade-offs were accepted. In deployable automation, intent is important because the safest fix is often the one that preserves the original design goal while correcting the failure. Filtering by author helps you locate the narrative of that design goal. Text filtering, such as searching commit messages for keywords, is another practical technique, especially when teams use consistent language in commit messages. If your team uses a ticket identifier, a feature label, or standard phrases like retry, timeout, or dependency update, you can search for those words and quickly gather the related commits. This is where good commit messages pay off. They make filtering effective. For beginners, the lesson is that your commit messages are not just for you. They are part of the future search interface for the project. In automation projects, where issues often reappear in slightly different forms, being able to find past fixes and understand how they were applied can prevent repeated mistakes. Text filtering helps you build on prior learning rather than rediscovering the same conclusions under pressure. Under stress, the fastest path is often to reuse known solutions, and filtering helps you find them. Filtering also applies to understanding what changed inside commits, not just which commits exist. A large commit history can hide the one line that matters, and you need a way to narrow what you inspect. Even when you locate the relevant commit, you might need to focus on a particular file or a particular type of change within it. The general idea is to reduce the amount of information you must hold in your head at once. Beginners often try to read everything and then feel lost, but experts are constantly narrowing the view. This is not a sign of laziness, it is a sign of discipline. Automation code can be dense, and mistakes happen when you skim too broadly and miss a subtle change in logic. Filtering your inspection keeps your attention aligned with the risk. Another perspective is filtering across branches, which matters because teams often have parallel lines of work. The same bug might be fixed in one branch, but not in another, or a change might exist in a feature branch, but never have been released. Filtering helps you answer questions like, has this change reached the branch that is deployed, or is it still isolated? This matters for automation because people sometimes assume that because a fix exists somewhere, it must be in production, and that assumption can lead to wasted debugging. By filtering history within the correct branch or between branch points, you can determine whether the deployed code actually contains the expected changes. This is also important when planning releases because you want to ensure the version you are about to tag includes the intended fixes. Filtering is how you verify that scope before you ship. There is also a human factor benefit to filtering, which is reducing panic and improving communication. When something breaks, teams can waste time arguing based on partial views of the history. If one person is looking at the whole repository and another is looking at a narrow slice, they may draw different conclusions. Filtering provides a shared method. Agree on the version range, the file path, or the time window, and then everyone is looking at the same evidence. That alignment is valuable because it turns the discussion from opinions into facts. In deployable automation, the fastest path to recovery is often a clear, evidence-driven understanding of what changed. Filtering is a technical way to support that clarity, especially when people are stressed and time is limited. To tie everything together, filtering techniques are about asking better questions and then narrowing its rich history to the smallest set of evidence you need. Filter by version tags to focus on release-to-release changes, by file paths to isolate impacted areas, by time to align with deployments, by author to find intent quickly, and by text to locate related work. These filters reduce noise, accelerate troubleshooting, and reduce the chance of fixing the wrong thing. For beginners, the skill is not in memorizing commands. It's in learning to treat Git history as a searchable dataset and to choose the right lens for the question at hand. When you can find the right changes and versions faster, you keep automation deployable because you can respond to issues with precision instead of guesswork.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.